Assalamu alaikum wa rahmatullah and welcome, beloved listeners and viewers, to the Voice of the Cape's YouTube and Facebook page. My name is Ameer Adams and I will be the presenter for today's Matric Revision session. And of course, this is the Voice of the Cape's online Matric Revision program for the year 2024. And this is proudly being sponsored by the Two Oceans Graduate Institute, an accredited online platform where you can become a primary school teacher or a high school teacher by studying in the privacy of your own home. If you'd like to find out more information as to how you may do this, you may visit their website, that is www.togi.ac.za, or you may call the number 021 829 7015. For today's session, we have none other than our esteemed facilitator, our dear brother Ameer Rhoda, who is part of Supreme Scholar and is a tutor there, and he will be giving us advice and discourse pertaining to how we may prepare for mathematics paper 1. As you can see, this will be dealing specifically with number patterns and introduction to functions. So without further ado, as I always remind you, our beloved viewers, on the Facebook page and the YouTube page of the Voice of the Cape, if you know of matriculants out there in the community or are in need of these revision sessions, then please forward and share this link to them. Without further ado, we immediately hand over to our beloved brother Ameer Rhoda, who will facilitate today's session, and that is the session for mathematics paper 1. All yours, Habib. Bismillah.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hope all is well, inshallah ta'ala. So today we're going to do number patterns and we're just going to do an introduction to functions. So I just want to recap on what we did the previous lesson. The previous lesson, we just did an overview of a typical question 2, which is your patterns of paper 1. And basically, we just did we just had a revision. We just had a revision of the 3 types of patterns that you get. We dealt with general properties of an arithmetic pattern. We did the summation formula and an exam question. You can check that link out. It's on Facebook and on YouTube. You can watch that video and get all this information on there. So with that being said, let us go into today's lesson. So, Bismillah ar-Rahman ar-Rahim. Today we're going to also do number patterns, but remember, number patterns is a vast topic with different aspects of it. So, today's aspect we're going to do the quadratic pattern formula, and we're going to basically do an example. And functions. This is an introduction to functions, right? Specifically, the parabola function, and then the graph, just a depicting diagram of how the parabola look. So with that being said, let us go into today's lesson. So quadratic pattern, as you can see, the quadratic pattern, this is the general formula for a quadratic pattern. Same with arithmetic and geometric. It has a general formula. The quadratic pattern also have a general formula. Tn is equal to an squared plus bn plus c. Alright? Now, Tn is your general term. N stands for your number of the term or the term number, right? Now, A, B, and C, that is your coefficients. That are your coefficients, and you are basically required to work that out, right? So we will see how this is worked out. We will work through this accordingly. So, I'm going to show you how to solve a quadratic pattern. What is the steps? How do you go about it? All right? So, steps to determine the nth term. Now, when you see nth term, some students, when I'm tutoring them or teaching them, they don't know what nth term mean. Nth term is basically referring to the general term, right? So, step to determine the nth term, meaning the general term. Now, the first thing that you have to find is your constant difference. Alright? Your constant difference. Second term minus first term, third term minus second term, fourth term and minus third term, and so forth. And that's what you do for as you go along, right? Now, then once you get your, remember the quadratic pattern, what is the significance of this pattern? The significance of this pattern is that there's two differences. It has your first difference, which also forms a pattern, specifically arithmetic pattern, and then you have your second difference, which is a constant difference. A constant meaning the difference is not is it's the same throughout. Whereas the first difference, it's not constant, it also forms a pattern. Alright? And then remember I told you in the beginning you must solve your A, your B, and your C. Then you use the value of the second difference to find your A. Once you find your A, you use your value of A to find and the first difference to find B. Right? Use your A and B to find C. So I'm going to explain this in detail, but please take a screenshot or whatever the case may be, or write this down in order for you to not forget this, or for you to just remember this when solving the question. With that being said, let us solve the equation. So, Bismillah ar-Rahman ar-Rahim. Here, thus I determine the nth term of this following sequence, meaning the general term. So as we can see here, here's our term 1, term 2, and term 3, and term 4. So we have 6, 17, 34, and 57. Now, what I did was I subtracted 17 from 6, 34 from 17, 57 from 34. Alright? There I get my first difference. Now, can you see there? My first differences are different. Right? They are different. So, my second difference, right? My second difference is the same as I explained to you. It's the same. Now, I don't know if you recall me telling you that the first difference also has, it's also a pattern. It's also a pattern, an arithmetic pattern. So be prepared when you get an exam question. They can ask you questions on the first difference as well. All right? So, with that being said, this is what you do. This is your first step. This is what you need to do when you get a quadratic formula, a quadratic pattern. When you get a quadratic pattern, this is what you need to do. All right, as you can see. Please take your notes. Please take your notes. Take screenshots. Yes. So, first, what did I say? We have to solve our second difference. But this ways in which we do this, all right? So, basically, we have a second difference. If we go back, right? We have a second difference as 6. So, we're going to solve our A, B, and C. So, what we're going to do is we're going to take our second difference, known as D2. The D2 is equal to 2A. As you can see here, my second difference is 6. I'm solving for my general formula. I'm solving for my A. D2 is equal to 2A. So, I'm going to, in place of D2, I'm going to put 6 is equal to 2A, and A will equal to 3. And basically, that is division, dividing on both sides by 2. Okay, so we have our A value. Then, using the first difference to solve for our B. Remember, I told you the second step, you use those first difference and the value of A that you solved in the first step to get your value of B. Now, if you go back, our first difference is 11, 12, and 23. All right? Now, when solving your B, all right, I told you need to take your first difference and the value of A. Our value of A is, what is our value of A? It is, let's see, 3. All right? Now, the first difference is 11. Now, remember, if you go back to your question, if we go back to the question here, we have 11, 17, and 23. Now, you always take the first difference, the first value of the first difference. You always take that one, right? As you can see there, 11 is equal to 3A plus B. And then in place of A, remember we're solving for our B using our first difference and our value of A that we calculated in the first step to get our B. So by substitution, we substitute 3 in place of A, and then basically we carry the 3 times 3 is 9. We carry it over, becomes a negative value. So 11 minus 9 equals to 2. So B essentially is equal to 2. So that's how you solve your value of B. Now to get the value of C, remember what is your general formula? Tn is equal to A n squared plus B n plus C. So we have our A and we have our B. We do not have our C. So now, solving the general formula, we're gonna basically take our first term, term one or T1, and we're gonna say it's equal to A plus B plus C. All right. Now, if you recall that the first term, if you recall, the first term is equal to 6. All right. So basically, what we're going to do is we're gonna put in place of term one or in place of T1, as you all know it, 6. All right. In place of A, we're gonna put 3, and in place of B, we're gonna put 2. So that's basically how we do it, and then from there to get the C becomes very easy, and then we get C is equal to 1, and then all we need to do is we take our A, Tn is equal to remember Tn is equal to A n squared plus B n plus C. So it's going to be 3n squared plus 2n plus 1. Halas. So there we go. That's how we basically do it. That is our general formula for a quadratic pattern. Now, I just want to do some. I just want to add some comments to this quadratic equation or formula that we just solved. Now, let's say, hypothetically speaking, they ask us to calculate the term value 40, T40. What is the value of T40? So basically, remember your n is equal to your term number. All right? So we're going to say T40 is equal to, wherever you see n, you're just going to substitute 40 in place of n. You're going to substitute what? 40 in place of n. That's all. All right? And then you get the value of T40. Now, as I'm speaking, students, please make your notes and try to write it on a piece of paper, whatever the case may be, or on your phone, whatever platform you're using, and try to take these notes because this is very important to understand, right? They can also ask you a question like this. They can give you, let's say, 400. What is the term number of the value 400? Now they're reversing the question, all right? They're giving you basically Tn. They're telling you Tn is equal to 400 and you must solve for n. So you're going to have 400 is equal to 3n squared plus 2n plus 1. Then what you basically do is you just have to solve for n. And then it becomes a trinomial because you're going to carry the 400 over and the whole equation will be equivalent to 0. So in that case, you're going to have to use the quadratic formula, which was taught to you in our very first session a couple of weeks ago by Imam Nadir a couple of weeks ago. How to use the quadratic formula. So in that case, you can use the quadratic formula to solve your n, right? So that is common questions they can ask you. More questions they can actually ask you is on the first difference pattern. Now, the first difference pattern is also a arithmetic pattern. So they can also ask you based on your arithmetic properties. So like I said to you in the previous lesson that we had, it's very important to expose yourself to different types of situations and to expose yourself to different types of questions in order to prepare yourself for the upcoming trial exam and final exams. So yes, please go do all the questions that are on the internet. Is all the resources are on there. Please utilize all the resources on the internet, and I guarantee you that you will. I like to use this word, and I'll mention it again. A master in mathematics in every topic. So with that being said, let us go further. All right, that's just one example. I'm not gonna go more into detail. I think I've explained enough. All I require from you is to go do questions. All right, go do questions on your own. So with that being said, that's the end of patterns, all right? So sum to infinity, sigma, notation, all those type of things, please go revise it, work through questions, all right? From 2014 to 2023. I'm not sure if the 2024 May June paper's out already, but if it is out, please practice that question as well. Practice as much as you can. That's all I can say. That's the best advice I can give you. All right. So functions. Now we're gonna go into functions. Now the first functions is divided into three types of, or let's say four. It's the straight line. It's the exponential function. It's the hyperbola function, and it's the parabola, the quadratic function. Now I'm gonna start with this point. I'm gonna start with this form of the parabola. All right. Now a function, before I go into the parabola specifically, a function is basically defined as how one variable changes with respect to another variable. All right? How one variable changes with respect to another variable. You understand? So that is a function. Let's say, hypothetically speaking, you measuring distance with respect to time. You see, so one variable is distance and your other variable is time. So that is a function. All right. So nevertheless, we're gonna go into detail what with respect to the parabola. So as you can see here, the parabola is equal to y is equal to a open bracket x minus p close bracket to the power of 2 plus q. So this is a particular form. There's two forms of the parabola, but the other form I'm going to do some other time, right? Now the A value is very, very important to understand and to always observe the A value before going into the question. A greater than 0 meaning if the A value is positive, meaning if it has a positive value, right? A value greater than 0, the parabola will behave in this manner. The parabola graph will behave in this manner, right? It will be a smiling face, right? And there's also something known as maximum and minimum, which I'll come to you as we go along. Now, if the A value is less than 0, the parabola behaves in the opposite direction. And they usually label it as a sad face. It has a sad face, right? So that is the way the parabola behaves when the A value is less than 0. Now, if the A value is greater than 0, I would like to mention this. The graph experiences a maximum. The graph experiences a minimum. Right? So when the A value is greater than 0, the graph experiences a minimum. And when the A value is less than 0, the graph experiences a maximum. I'll explain to you this. As you can, if you look at this, if you look at this depicting diagram of the parabola, all right, arrows mean infinity. Arrows mean the graph is going to infinity. We do not know where the graph is ending. All right? Now, if the A value is greater than 0, if you look at the behavior of the graph or the behavior of the function, right, we can see that the arrows is going up, indicating that the function is going towards positive infinity. But look at where the graph is turning. Look at the turning point. Right? The turning point will have a low value compared to the loss value. The loss value, as we all know, is going to infinity. We do not know where that value is. Right? It's continuing, continuing, and continuing. So that is why we say the graph experiences a minimum. Right? Because its minimum value, it has a very small value in comparison to the positive infinity. If you look at the graph with the A value less than 0, that graph experiences a maximum. Why? Because the arrows is going downwards. So with that being said, the fact that the arrows is going downwards, that indicates to us that the graph is going towards negative infinity. Negative. Now, this is something you guys need to understand. The higher the negative value, the smaller the value, right? So if you compare negative infinity to let's say hypothetically speaking to 4 is greater than negative infinity. So that is why the parabola or the function with a negative a value will experience it will experience a maximum. It will have a maximum, right? So with that being said, I hope you guys understand that, because sometimes when I speak about minimum and maximum, students don't understand what they are referring to, right? So P, let's focus on the P and the Q now. The P and the Q is representing your turning point. Alright? It represents your turning point. Alright? So your horizontal, it also represents your horizontal shift. But we'll come to that. I'll explain to that afterwards, after we explain first the turning point. So P is your X value for turning point. P is your X value of your turning point. Alright? And it's also known as the axis of symmetry. So if they ask you what is the equation of the axis of symmetry, what you're going to basically do is, let's say you have y is equal to 2, open bracket, x minus 4 to the power of 2. Then if they ask you what is the equation of axis of symmetry, it will be x is equal to 4. If it's a positive value, and then that means that the x value of the turning point is negative. Alright? Because of the formula. This is the formula. Because a negative times a negative is a positive. Alright? So if they ask you what is the equation of axis of something, you're just going to say x is equal to p, or x is equal to whatever the value of p is, or whatever the value of the x value of the turning point is within your particular equation that you're dealing with. Alright? So that is your axis of symmetry. So symmetry is symmetrical. Halving the graph, it halves the graph. Alright? So it's very important to understand that point. Alright? And now I'll explain to you about the shifts. Alright? So it's also known as the horizontal shift, meaning moving left and right horizontally. Moving left and right. And right, so if the graph moves towards the right, you will minus, let's say, 4 units to the right. That means you're going to minus 4 within the x minus p bracket, within that particular bracket. Right? That is the horizontal shift. If you move towards the left, you're going to add. Now, the Q. The Q is the y value of the turning point. The Q is the y value of the turning point. Right? It's also known as the vertical shift. Also known as the vertical shift. Right? Meaning the graph moves up 4 units, you just add. It's not the same like within the bracket. It's just up, positive, you're adding. Right? If it's downwards, you're subtracting. Right? So that is the vertical shift. It's also the y value of the turning point. Now calculating, now what are we going to calculate? Now I'm going to give you an example and show you how to apply the knowledge with what I've just taught you. Alright? So, here we have our parabola. Now this is also steps that I'm going to explain to you that you need to understand, and I would like you to take some notes and to take a screenshot or whatever the case, whatever suits you. Please take this down. So when getting a question, when doing a question, you first need to identify your A, because that will determine your shape. Then find your x and y intercepts. Alright? So your intercepts, your x and y intercepts, where the graph cuts the x-axis and the y-axis, respectively. Alright? Once you find your x and y intercepts, you find your turning point. You need to calculate the coordinates of your turning point in order to sketch the graph. Alright? And then once you have your turning point, you can plot the points and sketch the graph. Okay. So please take notes of that. I'll just give some time for you guys to write it down. We'll take a screenshot. And then I'll move further on. I'll move on. Okay, I'm going to move on now. Alright? Example 1. Here they give us sketch fx is equal to x plus 1 to the power of 2 minus 9. Now, they're not telling us, they're not giving any value in front of the bracket. Now, if I may ask you, You can answer to yourself, of course. If you have x, and I ask you what is the coefficient of x, you're going to tell me it's 1. Even though there's no value, there's nothing in front of x. If I ask you 2x, you're going to tell me it's 2. But why? When there's only x, you tell me it's 1. Because when there's nothing in front of a particular variable, let's consider the whole bracket as a variable. That means whatever's in front of the variable, right? If it's nothing, automatically the coefficient is 1. So automatically the a value is 1. And as we can see, there's no negative, so automatically it's positive. So we know already the behavior of the graph. We know already how the graph is going to look. We have some sort of idea, right? And we see it's plus 1. So according to our understanding, that the formula is x minus p within the bracket. So that means that we're gonna have a negative turning point, a negative 1. All right, so that means that x value is equal to negative 1. And we have negative 9, so that is our y value for our turning point. We can already see that. All right, as we know from our understanding of the general formula of the parabola equation in this form. So now, Bismillah ar-Rahman ar-Rahim, they say shape is a is greater than 0, therefore the graph will behave that way. It will behave in a positive manner. X-intercept, y equal to 0. X-intercept, you make y equal to 0. Can you see there? Let us solve the x-intercept. So we did our first step. Second step is solving our x and y intercepts. So you make y equal to 0, fx, gx, hx, whatever the case may be, is also known as y, right? So you make your y-intercept equal, you make your y equal to 0, solving x-intercept, put 0 in place of y, you multiply your x plus 1 twice out, carry the 9 over, right? Or you can solve it that way as well. You can multiply your x x plus 1 to the power of 2, you can multiply it twice out, or you can carry the 9 over, all right? And then square root on both sides. So that is 2 methods you can use. You can use either one you want to use, right? In mathematics, there's different ways to approach the question. There's different ways to approach a particular situation and come to the same destination. All right. So whatever method you choose, of course, it must make sense. Of course, all right. You can choose whatever method you want to choose. So if you want to choose the method of x plus 1 to the power of 2, where you multiply it out algebraically, and then solving it by using your trinomial concept, no problem. You can do that as well. All right. The concept that we used tonight was we carry the 9 over, and then basically we square on both sides to get rid of the 2. All right. And then square root of 9 is 3. So remember, when you square root something, always going to have a positive and a negative answer. All right. X plus 1, and then we have plus 3. Positive 3 is equal to x plus 1. And we have negative 3 is equal to x plus 1. And then from here, simplification, we're getting our answer. X is equal to 2, or x is equal to negative 4. So that is our x-intercepts. So we have our x-intercepts. So that is how we solve our x-intercepts. So now we're going to solve our y-intercept. Now when you solve your y-intercept, you make x equal to 0. Am I right? When solving x-intercept, you make y equal to 0. When solving for y-intercept, you make x equal to 0. All right? So there we have simple, straight, put it just so in the calculator. Y-intercept is always the easiest to calculate. And we get y is equal to negative 8. All right? Just to comment on this part here, just want to make a comment before we continue with the y-intercept. The coordinates will be 2 and 0 and negative 4 and 0. Right? In coordinate form. Sometimes the questions want it in coordinate form, and then you put it in coordinate form. Sometimes the question don't want it in coordinate form. So it's very important to also read your question with understanding and obeying what they want from you. All right? Obeying and abiding by what they want from you, and do it and how they want, according to how they want. Right? So if you should write this in coordinate form, it will be 2 and 0 and negative 4 and 0. Now this will be 0 and negative 8. Because remember, you made x equal to 0 for the y-intercept. And for the x-intercept, you make y equal to 0. That is why we have the actual x value and a 0. All right? And for the y-intercept, you have a 0 and a y value. Now, yeah, that's basically our second step. Third step is the turning point. Now the turning point from this form that we have it in. Right? From this form that we have it in, the turning point can be seen from the graph. But in the other form, which I'll teach to you in the next lesson, inshallah ta'ala, and then there's ways in which we calculate the turning point. There's two ways. Actually, I think there's about three ways, yeah. The alternative turning point method. But I'll just teach you the two ways, right? That's important for you. That's sufficient for you to know. Yes. So yeah. So but from this formula, you can see the turning point. Right? So our turning point will be -1. I told you it was x plus 1. So that means that because of our standard formula being y is equal to a x minus 1 to the power of 2 plus q. So because that's our standard formula, that means that that negative had to be multiplied by another negative to get it into a positive. So therefore we conclude x is equal to -1 and now y value is equal to -9 from the formula. Axis of symmetry, x is equal to -1. That is our axis of symmetry. Equation of axis of symmetry is x equal to -1. If they have to ask you to draw the axis of symmetry, which I don't think they will, but you never know, they can ask you that. It's just a straight line down. It's almost like it's not an asymptote. I'm not saying it's an asymptote. I'm just saying it's like an x asymptote in your hyperbola function, right? Which we'll do further in maybe next week or in a couple of weeks time, right? So your our x value is just a straight line down, halving the parabola, right? So that is our turning point, our axis of symmetry. Now, this is another concept that I want to explain to you that you need to understand domain. Now, what is domain? Domain is where all your x values exist. Is where all your x values exist. That is your domain. Alright? So your domain is where all your x values exist. Now, you basically gonna write an expression, a mathematical expression for your parabola function that represents how the function behave to with respect to your x-axis, how the parabola graph behaves with respect to your x-axis, how the graph behaves with respect to your x-axis, right? So x is an element of all real numbers. That is your domain of your parabola graph. Now, x is an element of all real numbers. Now, many students don't know what this means. They don't know. They don't understand this. What this basically means is that the x value can be any value between negative infinity to positive infinity. It can take on any value. It can take on any value, right? Between negative to positive infinity. You can even, there's an alternative way to write this. You can say x is an element, curly bracket, a negative infinity to comma, positive infinity, close bracket. That's an alternative method to use. All right? Some students use that method. Some students prefer x is an element of all real numbers. No problem. Right? There's no problem. Whatever method you want to use, you can use the method. All right? Now your range. What do you think your range is? If your domain is where all your x values exist, that means your range has to be the opposite. That means your range has to be the opposite. Now your range is where all the y values exist, where all your y values exist. Now, this is going to be a little bit different. Because remember, I explained to you that you have your maximum and you have your minimum. All right? The graph with an a value greater than 0 experiences a minimum. All right? A graph with a value of less than 0 experiences a maximum. Now, the minimum and the maximum refers to the y value of the turning point. It refers to the y value of the turning point. All right? Because remember, your range is to do with your y values. All right? Now, here they say y is equal to and greater than -9. Y is equal to and greater than -9. Or greater than and equal to -9. Alright? Now let us go back to that function. if you look here, as you can see how the graph is behaving, right? We have our turning point, we have our x value, our turning point, and our y value. It's going towards positive infinity. Now, where the turning point is, the y value, alright, the range will be equal to that -9, and it will be greater than -9 as well. Why? Why greater than -9? Because -9 is your minimum value. It's your minimum value, and the graph is going towards positive infinity with respect to your x-axis. It's all about how the graph is behaving. It's all about what you see from the graph, how the graph is behaving. Alright? So our range is we all have y values exist. So with that being said, that it's basically we're looking from our y value of our turning point, and we're seeing how the graph behaves from that point upwards or downwards. In this case, upwards. Alright? So that is why if we see here, our range is y is greater than and equal to -9, meaning it's going towards positive infinity. If the graph had to be rearranged with an a value less than 0, right? And let's keep the turning point. Let's keep for the sake of just for the sake of it. Let's just keep it for the sake of it. Let's keep the y value of the turning point as -9, and let's change the graph to a a graph that behaves towards the negative infinity region, right? Meaning it's gonna have a sad face. So that means in the range will be different. The range will be less than and equal to -9, right? Because now the graph is experiencing a maximum going towards negative infinity as well, right? Is our smallest value. So with that being said, that is how we do our range. Alright? And this is the manner, this is just mathematical expressions according to how the graph is behaving. How the graph is behaving. Remember, according to what I told you in the beginning of the session, alright? A function is how one variable behaves or changes with respect to another variable. Alright? So how the x changes and how the y changes towards one another. Right? Now what we're going to do is with Nila, we're gonna plot the graph, we're going to use the knowledge and all the calculations that we did, and we're going to plot the graph. Alright? So this is how the graph will look. As you can see, our x-intercepts -4 and 2, our turning point -1 and -9, and our y-intercept as -8. That's how you plot the graph. Now, if you look here, I just want to make some comments on this. -9 is your minimum value, right? And it's going towards positive infinity. Y is greater than and equal to -9, all right? Our y-intercept is -8. Our x-intercept is -4 and 2. Now, the graph, with respect to the domain, it means basically the graph can take on any value between negative infinity and positive infinity. And the domain will be the same, even if this graph must be reversed. Even if the graph must be reversed, even if the graph must have a negative a value, the domain will still be x is an element of all real numbers. Because as this graph is going up, it's going towards negative infinity with respect towards the x-axis. Please take into consideration what I'm telling you. As the graph is going up with respect to the x-axis, it's going towards negative infinity on the left hand side. With respect to your right hand side, it's going up with respect to the x-axis to positive infinity. It's very important to understand it when writing a domain. Alright? For your range, you're only looking at your y value. You're not looking at your x-axis. You're only looking at your y-axis. Right? So the graph is coming up towards positive infinity with respect to your y-axis for your range, and our minimum value is equal to -9, our turning point. Alright, so that is how we do this type of question. So, alhamdulillah, that is all I wanted to do for today. Alright? So, bi'ithnillah, inshallah ta'ala, I will continue next time and we'll go into more detail with the functions. Alright? So, with functions, I just want to elaborate a bit here because this is one of my favorite topics. I love doing mathematics, it makes me excited. Right? I love working, I love a challenge. Alright, guys, this is one thing I would like to share with you. Don't be scared of a challenge. Don't be scared of doing something that you maybe will dislike, or something that you do dislike. Sometimes people dislike things because they struggle with it. If you struggle with it, it's okay. Every person, I also struggled with maths at one point, but I kept on sitting, I kept on practicing, and Alhamdulillah, with the qudrat of Allah subhanahu wa ta'ala, with the permission, bi'idnillah, with the permission of Allah, Alhamdulillah, I managed to overcome that struggleness, and I persevered, and I managed to understand the concepts in mathematics. So that applies to everything in life. Whatever you encounter, right? Don't be afraid to fail. If you make mistakes, it's okay. That's how you're going to learn, right? If you make a mistake, that's how you learn, right? Because if you don't make mistakes, you're not going to learn anything, right? So I always tell students is make as many or as much possible mistakes as possible during your practice, during your preparation, than to make the mistakes in the exam. Now you're going to prevent making mistakes in the exam. Is to practice, is to prepare, is to expose yourself to different types of situations, meaning different types of questions. Alright? So, with that being said, practice as much as you can, alright? So don't be afraid to struggle. Don't be afraid to sit up at night and struggle with those questions. Don't be afraid of that. Push. It's almost trial exams. Every hour count, every second count. Right? One of my friends, one of my best friends, always told me this. Every second is half a mark. Every second is half a mark. Half a mark for every subject. Yes, so that was our mindset, right? Now I had a good friend that used to push me, you know, and it enabled me also to push me above what I thought I could achieve. All right, so it's also important if you're able to befriend someone that can also motivate you, or befriend people that's perhaps better than you. You can learn from them, and become a better version of yourself. So with that being said, I won't talk any further. Alhamdulillah Rabbil Alamin. Shukran for listening. Assalamu alaikum wa rahmatullahi wa barakatuh.
MashaAllah, we say shukran, jazakallah khair, and Bait Ramakasi to our beloved brother Ameer Rhoda, who gave over today's discourse on mathematics paper 1. As a reminder to all of our beloved listeners, in conclusion, to please share and forward this link to all of those who are preparing for the trial examinations and, of course, the end of the year NSC exams, inshallah. We ask Maaf and apologize for the delay on our side. There are some technical glitches here on our side, but we once again would like to thank everyone for tuning in and for viewing rather today's session of Mathematics Paper 1 conducted by our brother Ameer Rhoda from Supreme Scholar. And as a reminder, this is a Voice of the Cape's annual Matric revision sessions in collaboration being sponsored by the Two Oceans Graduate Institute. And from my side here from the studio, we'd like to say thank you very much. Shukran, jazakallah khair, and baitra makasi to everyone for tuning in. Until our next session, inshallah, we say wassalamu alaikum wa rahmatullah.